Hi everyone, welcome to my YouTube channel. My name is Umoru, and in today's video, I'll take you through my climate data analysis project. We're going to load real climate data from Kaggle, clean it, and create visualizations to uncover insights about temperature trends in Nigeria and globally. During this analysis, we're going to answer some questions like how have temperatures changed globally from 1961 to 2022? How do temperature changes in Nigeria compare with other developing or developed countries? And finally, which countries had the top 10 highest temperature anomalies in a given year, say 2022? Before we continue, I'd like to show us the data sets I'll be working with in this spreadsheet format. Here's the data set. We have the object ID, country, ISO 2, ISO 3 indicator, and a lot of other columns. We're not going to need all these entries, hence the data cleaning that we are going to do in due course. Here's the setup. I'm going to use the Google Colab platform to conduct this analysis. It's a powerful platform that runs the Python programming language with codes. And in this particular analysis, I'm going to use the notebook that has the markdown and spaces for coding. So as you can see, the heading here is showing the overall heading of this analysis. And then I have the subheading that shows the various contents that I'm going to do in this analysis. So firstly, I'm going to load in the libraries that I'm going to need for this analysis. And particularly for this, I'm going to need pandas and matplotlib. Pandas is used for manipulating the data frame I'm going to be using, while the matplotlib will be used for data visualizations, as we're going to see in due course. So I'm going to load in my data set, and beforehand I had uploaded the data set that I'm going to use onto the environment. And this is the climate change indicators CSV file. So I'm going to go. The very first step is to load in the data set. With this line of code, I'm able to run and load the data set. I'm going to call this data frame CC, signifying climate change, as it is at preferred. Yes, this is a preferred nomenclature in this case. So equals to pd.read_csv. And since the file has been loaded onto the environment already, I just have to reference it and bring it here. When I load it, but before that, I have to load the codes that import the libraries that I'm going to use. Now we have seen it loaded. Then number one. So then I load my data set and view the first 5 rows in this data set. You can see the object ID, country, ISO 2, ISO 3 indicators here shown. All right, so with this now, I want to see the overall number of columns and the number of rows in this data set. So with this code, the shape function, I'm able to show that we have 225 rows in this data set and 72 columns in the data set. And yet, I still want to view the various columns in this data set, because from here, I'm not able to see what is in between, because the environment is not enough to show. See how it is bringing all these dots, showing that there are things in between that are not shown. But I want to see them, and hence the codes to show the shape of the code to show the various columns in this data set. When this is run, I see that we still have the object ID. It's creating a list of columns that I have in this data set, all 72 of them. So let's go further. Like I mentioned earlier, I'm not going to need all the columns in this data set to perform the analysis. I only need the countries and the various temperature values from 1961 to 2022. So what I simply do, the method I use here is to copy the columns, the list of columns from this particular output, put it here, then comment out the ones I do not need by simply adding the hash character. And when that is done and I run the code, I see that this particular, let me highlight it, this and the remaining parts here will be removed from the data frame. So once I view the shape now, I see that it's no longer 72, but 63 columns as opposed to 72 here. So that is done. The very next step is to clean the data. I like to see the number of NAs in this data set. With that, I'll be able to know which rows to drop or which columns to drop. And then with this line of code, cc.isNA, this function will return the NA values in this data set and the sum of the NAs that we have in the data set. We see that in 1961, we have 37 entries that are NA in this particular column, like that, like that. Still, I still want to go further to view the rows that have these NAs in them. When I run this line of code, I'm going to call this variable or this data frame NaN, signifying null values. When I open it, I see that a lot of them, like in Armenia with index number 9, we have NA values almost spanning across from 1961 to 1969. It means I'm going to treat these nodes before I arrive at a data set that is clean and with great quality for my visualization. Here, I'm going to run this code, this line of code drop NA with the function to remove the NA values from the data frame, because I'm not going to need them. They're going to skew the data set at the end of the day. Then I view the first 20 to see whether it has really dropped the NA values from there. So we see here, country like American Samoa with index number 3 has been removed from the data frame. We don't have index number 3 in this data set that we now have. So from number 2 now jumps to 4. We're going to treat this later. So this is the first 20 rows of the resulting data frame. We see the shape. We see that we now have 158 rows instead of how many before? 225. Yeah. All right, let's go further. This is data cleaning that we're doing. I want to see the columns too. After dropping the columns the other time, we should have viewed to see how the columns look like. Now we see that we only have countries, the year columns, and their corresponding entries for the the values of the temperature for the respective years. The next thing I'm going to do here is to check the data types to ensure that the data types are integer. For example, the temperature values are numbers, numeric data, and specifically in this case will be integers because they have decimal values. And the form we have here is float. Float is a form of the integer. And from the look of things, we see that we have correct data types. Country is as object. We're okay with that. Then the year with the values in them are floats. And before we continue, we see some issues with the namings of the year. Sorry, not the year, the namings of the country. We have Afghanistan here. Then there is a comma before Islamic Republic of. Yes, we do not have it as appropriate name. We only want to see Afghanistan as the name of the country, just as we have Albania here, then Andorra as the name of a country, removing this principality of whatever is there. We only want to have Angola like the way we have here, and the rest of them. We're going to treat this as to make our data clean at the end of the day. So with these lines of code, we view the names of the countries. Look at it now from here to here. This should be for Afghanistan, but we do not need after this comma, that is before this comma and to this particular word of. We're going to treat it and remove it from this to make the name cleaner. And that is what we have across the name, most of the names here. So the next operation will be to extract just the country names without this additional info that we have mentioned. For example, with this Islamic Republic of Iran. So what to do here is to introduce the lambda function that will split the additional infos after the comma punctuation in the names. For example, let's bring another country that has this Andorra here. From after Andorra, before the comma, we want to split and remove everything here so as to be left with only Andorra. So running this line of code will do exactly that, and we'll view to see that the operation has been conducted. We have Afghanistan, Albania, as opposed to having Afghanistan Republic of. Yes, if you are following. So with that done, the next operation we're going to do is to check for duplicates and treat it appropriately. First, we check for duplicates. We see that China with index number 41 is a duplicate. 42 is also a duplicate. 105 with Korea has been entered twice. So we do what we call drop duplicates with the function. The duplicates will be removed from the country. Let's see the resulting shape of the user frame that we have at the end of the day. We now have 155 instead of 158 as we have here before removing duplicates. So we'll continue. We have treated duplicates, and we're almost done with the data cleaning aspect of this analysis. But before that, we have to reset the index. As we have here, the index numbers are irregular. After number 2, we're supposed to have number 3 before number 4. But because of the operations, removing and dropping NAs, it now becomes irregular. So we reset the index with this line of code. And then Another thing we notice is that the column header has F before the year. That is not necessary for this analysis. We're going to remove the F from the column name using the string replace of operation. We're removing the F and replacing it with blank space. When we view it, we now see that we really have clean year and yes. With this now, we can go ahead to visualize our data. Yes, I'm starting with Nigeria. I'm going to extract the data for Nigeria and calling it NG, calling the data frame NG, and going to query it out, looking for the word Nigeria in the entire data frame. I run this code. It brings Nigeria with index number 104 and the corresponding temperature values in each year from 1961 to 2022. And now I'm going to plot the graph to visualize how temperature has been changing since 1961 to 2022. So this is the code that I'll be using to do this. I'm first of all going to create a variable because the country of interest I'm going to need here is with lock number. This is the lock function because the index is at 104. I'm going to lock it to bring it out to single Nigeria with index number 105 out of the entire data frame and call it country of interest. Then country name will be the country of interest singled out from the country row. And then the year will be from the country of index. This one then column is a function that excludes column, the country column from the entire row. This row column, Nigeria, is not needed in this particular operation. And this particular one is to bring the figure size and the plotting. The other parts added here are the various title, the labeling to make the figures beautiful at the end of the day. So when I run this code, I'm going to bring a very beautiful visual showing the trends of temperature from 1961 to 2022. So with this now displays a single Nigerian chart, and this plot shows the average temperature in Nigeria since from 1961 to 2022, and we notice a steady upward trend. That is a clear indication of global warming. We see that it is increasing. The graph is showing an upward trend, an indication of global warming over the decades. So let's move further to visualize other and compare Nigeria with some other countries using codes with countries of interest like Austria, Bangladesh, and Nigeria alongside Nigeria. I'm going to run this code to show the plots at the end of the day. So this is the plot that shows Nigeria alongside two other countries. Here too, we see that each line represents anomaly in average temperature over time. Here, the blue line represents Austria and its own trend is going like this. Here, 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 like that. Nigeria has the green line. Nigeria has this green line. It's consistent with the visuals that we had in the first place. Again, in this visual, we see upward trajectory across these countries. We see that the temperature is increasing across these countries. What is this showing us? Is this visually telling the story that the globe is getting warm over the decades? Let's move further to checking for the highest temperature in a particular year. With these lines of code, we can see that for year 2022, the highest country with the highest temperature is Andorra. Yes. And the last visual for the day is to see the top 10 countries with the highest temperature. The top 10 countries with the highest temperature, using a grouped bar chart to show these countries. And with the lines of codes here, I'm able to see the data frame of the top 10 countries with the highest temperature over time. And we see that when visualized with these particular lines of code, we have the countries Andorra, France, Switzerland, Monaco, Netherlands as countries with the highest temperature values in the year 2022. So conclusively, this analysis shows that across this visualization, the message is the same. Temperature anomalies are rising globally. Data analytics like this can help us quantify climate change and inform better policy decisions. If you'd like to see more of projects like this, subscribe to my channel for tutorials and insights. Thank you.